Okay, we're going to try this again. We are going to look at piecewise functions. If you notice, I have this new little app that I'm going to try to use. And actually, I did this lesson earlier and it did not download. So I'm going to do the exact same one on the whiteboard app. And then whenever we get to our actual graph, I'm going to refer to this graph right here. Okay, so here we go. So this is piecewise functions. Sorry, give me 1 second. Piecewise function is going to be a function made up of other functions that occur at different intervals. Okay. So what it would look like is it would ask us to evaluate at given values. And it would tell us that f of x is equal to, and it would have like a brace. And here we have 5x plus 3 if my x is less than 0. So that's my condition. That's actually very important. I have to know that. And then the other function that I'm given is 3x plus 6 if my x is greater than or equal to 0. Okay, so I'm wondering, I guess I just write on this and then clear it. That's what makes sense. Okay, so those are my conditions. Those are my two different functions. It wants me to find a, which is f of -2. It wants me to find b, which is f of 0. And it wants me to find c, which is f of 2. So if I find a, right here, if we find a, which is f of -2, first I need to look at my conditions, and I notice that -2 is less than 0, so it would be right here, which means you use this function. Okay, so what I do is I plug -2 into that function. So I get 5 times -2 plus 3. If you look at 5 times a -2, 5 times 2 is 10. Signs are different, so it's negative. And we have our 3 right here. Signs are different, and I'm combining. So what I do is I subtract, and I keep the sign of the larger. So -7 would be f of -2. Just have to make sure that you use the right function. So make sure you pay attention to the conditions. For our b, it is telling us to find f of 0. So when I look right here, I know it's not going to be that top function because it's telling me f of is less than 0, and 0 is 0. So it would actually be right here where it says x is greater than or equal to 0, which means we use this function right here. Okay, so if you plug that in, let me go ahead and delete that before, because I kind of saw it was going to delete my writing. This is different than that other thing that I've been using, but my pen doesn't work as well. Okay, so that was a 6. So we plug it in, we have 3 times 0 plus 6. 3 times 0 is 0 plus 6. 0 plus 6 is 6. And then lastly, it gives us C, wants us to find f of 2. That would be this condition, which means we would use that function. So if we plug it in, we get 3 times 2 plus 6. 3 times 2 is 6. Signs are the same, so it's positive. If we add a 6 to that, we get 12. And so that would be evaluating at given values. Okay, so I'm pretty sure I can use this lasso right here. And then delete. Okay, so now what we're going to do is look at this piecewise function that they give us. And what they give us is f of x equals our brace. We have a negative 5x. This is if x is less than or equal to 0. And then we have negative 2. This is if x is greater than 0. I'll write up top because I can't change pages. What it's telling us to do in this problem, our A says to graph, and then our B says to determine our range. And a very important thing that they tell us is that the domain of this function is all real numbers, written in interval notation. What we have is the interval negative infinity to infinity. Okay, so the first thing we're going to do is we need to look at A. It tells us to graph. In order for us to actually graph our negative 5x, we need to have some points that we're going to graph. If you look at our condition, it says x is less than or equal to 0. So I know that my x values are less than or equal to 0. Okay, so if I actually plug these in, what I get is negative 5 times 0 equals 0. Negative 5 times a negative 1. 5 times 1 is 5. Signs are the same, so it's positive. Negative 5 times a negative 2. 5 times 2 is 10. Signs are the same, so it's positive. And then negative 5 times a negative 3. 5 times 3 is 15. Signs are the same, so it's positive. Okay, so I'm going to show you how I graphed this whenever I originally did this problem. So if you look right here, I get the same values right here in the pink. And if you notice, there is the pink part of my graph. That is negative 5x. Okay. So now what we're going to do is we're going to find points for our negative 2. We need x values and we need y values. So if you look at the condition, it tells me that x is greater than 0. This is saying that it's strictly greater than 0. You have to start with this boundary of 0 though, because if you start with the number 1, you'll notice that you actually cause the graph to be discontinuous at a point, which would contradict our domain being all real numbers. Since all real numbers are included, there's not a jump in our graph. So that is why, even though the condition states that x is strictly greater than 0, whenever we use, when we're finding our x's and our y's, we still start with 0. The only thing is, on our graph, we'll use an open circle instead of a filled in circle. So the condition tells me that, okay, because this is my f of x, that's really y, right? So this is telling me y equals -2 for all values greater than 0. So y is -2 for all values greater than 0, even 0. I actually think we might be able to graph this on here. It's just going to have to be with my own handwriting. So let's see. So we have y, we have x. If I look, I need to go to at least 15 on my y-axis. So I'm going to do 2, 4, 6, 8, 10, 12, 14, 16. And then on my x-axis, I really only go to 3, so we could do 5, but we can go ahead and keep it even, and we'll also do 8 notches for 16 as well. 2, 4, 6, 8, 10, 12, 14, 16. 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I was in red a second ago. I am going to go back to red to graph my -5x function. I notice that at x is 0, my y is 0. So that would be right here. And then I notice that at -1, my y is 5. So when my x is -1, my y is 5. I went up by 2s, 2, 4, 5, right there. When my x is -2, my y is 10. May need to scoot that over just a tad. 2, 4, 5. And then I notice, okay, so -2, 10. 2, 4, 6, 8, 10. It's like right there. If I do 3, I get 15, 12, 15, 2, 4, up. It's doing that right there. Oh, I thought it would let me delete the whole thing. Okay, so that is what my line is doing, and it's just going that way, right? So if we do our blue, and I look at my x being 0, my y is -2, and it cannot include it because that's what my condition tells me. It's strictly less than. So if I look at my x being 1, my y is -2. I look at my x being 2, my y is -2, 3, 4, 5. It's going to continue to go on and on and on. Okay? So now what it wants me to do is determine my range. Now my range, that's my y values. So I read that starting here and going up. Okay? If you start there, you notice the first thing you come to is a point. Is actually a point on the y-axis that is -2. And then I notice that if you go up even further, you end up getting to 0, and it does include 0. I'm going to union that with 0. And then I notice that it's continuing to go up, 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 up forever. So we get infinity. So that would be a picture of my graph and finding the range of that piecewise function. Okay, thanks y'all.